everyone, welcome back to another lesson. Today's learning goal is I can graph the solution of systems of two linear inequalities. So we've already done graphing linear inequalities. We're going to be graphing systems of two of them, and we'll talk about what that means in a moment. So let's go ahead and get started. So a system of inequalities is a set of two or more inequalities in the same variable. With the same variables. The solution to a system of inequalities includes the set of ordered pairs that make all the inequalities in the system true. Okay. In graphing a system of inequalities, the solution set is represented by the intersection or the overlap of the shaded regions. So, for example, here it says to graph the following inequalities and state whether the following points, 0, 0, 4, -3, and -2, 3, are going to be part of this system, if they will work and make these inequalities true. Now, what we could do is we could plug all these in to both of these and see which one makes both of those true. But another way we can do that is by graphing both of these inequalities onto a coordinate plane. So here, because this does not have an underline right here, we're going to use a dotted line. Remember that? So it's going to be a y-intercept of 2 with a slope of 2, so our line should look something like this. And it says that y is less than that, so we're going to be shading towards this area. So we're going to shade all of this over here. And then this one says y is greater than or equal to -x minus 3, so we're going to have a point at -3. And it's going to slope downwards by 1, and so we're going to have a line like that. Okay. And it says y is greater than, so we're going to be shading everything above that. Let's do that in blue. And the solution set to all of this is the area that is shaded by both of them. Okay, shaded by both of them. So that would be if I get rid of all the other stuff, where it's doubly shaded. Okay, you can leave that stuff there as long as you know that this is the area that shows where the solution set is. That means any point inside the shaded region, if I were to plug in that point, so let's say if I were to plug in, this would be 6, 0 right here, 6, 0 right here. If I were to plug in 6 for x and 0 for y, I would make true statements in both of these. Okay, so it says, is 0, 0 part of our solution set? Well, 0, 0 is right here, and that is part of the shaded region, so therefore, yes, it is part of our solution set. Is 4 -3? Well, 4 -3 is going to be 1, 2, 3, 4. 1, 2, 3, so it's going to be right here. That's 4 -3, so it is part of our solution set. And then over here, -2, 3. So -2, 3 is right here. That is not part of our solution set, so therefore, no, it is not part of our solution set. Here it says graph the following and state whether the following are ordered pairs again. So we have y is less than or equal to 1/2 x, so that's a y-intercept of 0, 0. And that's going to be a complete line, not a dotted line, because it also includes points on that line. Here, if we flip this over, we get y is less than -x minus 4. So that point, 0, -4, is going to be right like that. And to shade our regions, here we're going to be shading underneath the green line, and here we're going to again be shading underneath the green line. So that means our solution set for both underneath them is going to be in here, in this area. So it says, is 0, -4 going to be part of the solution set, which is right here. Notice how it's on the dotted line, though. And remember, if it's on the dotted line, we don't include that. So it's not going to be part of our solution set. Here, it says -3, -6. -3, -6, that's right here. So that is going to be part of our solution set. 0, -5, 0, or -5, 0, excuse me, -5, 0 is going to be right there. So that is not part of our solution set. It's not part of the shaded region. Okay. Go ahead and try this one out on your own. What you should have found is that it looks like this, because if we were to change this second equation to slope-intercept form, it would be negative 1/2 x plus 2. Y is less than negative 1/2 x plus 2, so we're going to have a dotted line going down with a slope of negative 1/2, y-intercept of 2. And remember that y equals negative 6, or y is greater than or equals to negative 6, is going to be a horizontal line at negative 6. And our shade region is going to be what's in between. Go ahead and try this one out on your own. Here we have a solution set of no solution, excuse me, and so that is because here we're going to be graphing above this line. Okay, so right here is the 2x plus 5, and we're going to be graphing above it. Here we're going to be graphing below 2x minus 4. These two lines are parallel. Okay, and since we're graphing in opposite regions, one going up, one going down, therefore there is no solutions to this system of inequalities. Toby believes that if the lines in a system of inequalities are parallel, there will always be no solution to the system. Do you agree or disagree? Explain your thinking. Well, we could have very easily graphed the other way. So, for example, if this inequality instead was this way, okay, instead of graphing this red region right here, we'd be graphing this region over here, like that. And so then, therefore, the solution set would be all of the stuff in blue that I'm shading right now. Okay, so therefore, just because they're parallel doesn't mean that they are going to be no real solution or no solutions to the system. Okay, if we shade the other way, it could have created a solution set.